Hello friends, today I'm going to explain you Dijkstra algorithm. The Dijkstra algorithm is basically used in computer networks to find the shortest distance between two nodes. So for any two nodes, suppose we have to find the shortest distance. Why we use shortest distance is basically that suppose I have a packet available on this side and I want to send it to J, then I want to spend less time, less distance while the packet travel from one point to another. So basically this is the distance which is written between for these two, or you can say sometimes it's also said as cost. So if you are transferring from this node to node B, then this is the cost. You are transferring anything from B to D, then the cost is 3. From B to 12, the cost is 12. And these cost basically depends on certain factors like the distance, the wire used between two nodes, and the environment through which the nodes are connected to each other. These are certain factors. So we want to reach the destination node taking the shortest path. And this shortest path is used by the router to update its table. I'll go through the details how a router works, how a switch works, when I'll go send you the videos of the chapters. And the reason being I'm doing this thing is that discuss algorithm, and the another one is so that I can give you some assignment which will be equivalent to your work which you will be doing for labs. So suppose we have to find a distance, shortest distance between node A to J. So how you start is that first of all you always select your starting node. So let me bring a table and so if I have a table here, the table is something like this. Let me exit this table. It's creating a lot of trouble. Right here. I think so finally I managed to bring it here. Now suppose we have to find the shortest distance between A and J. So the first thing which you are going to write for the Dijkstra algorithm is that you will mention your starting point or starting vertex or starting node, whatever you want to use. So starting node, then you will write all the nodes which are possible in the network. So what nodes we have possible is we want to start from A, so you write A here, then C, your D, E, F, G, H, I, and J. Now, because we are starting from node A to J, maybe the network might ask from you to start from B to J. So then your starting node will be B, and you will mention your A here also, because you have to write the remaining nodes, which will make you reach to J. So now I'm on this node. So what is the cost for me to reach to this node? So whatever the cost is, you will mention it here 4, and then comma, you are starting from which node? Means you are using the route or the path from which node, you will mention it here. It will be through A. means you are emanating, or the starting point is A. Then what A is connected to, the whatever the remaining nodes which A is connected, you will mention it. Then C, the cost is 5, and you will travel through A, means obviously you have to use the node A. D, it's 8 comma A. Now for all these remaining nodes which are not connected to A, there's no direct path possible, means you can't go to E directly because this is not given to you. So for them it will be infinite. You will mention it here, INF, or you can say INF is your infinite. So it is infinite. You can use the special character INF infinite also. I'm just using this here. So it will be, because there is no route discoverable for them from A directly. Now, whichever is the minimum cost, which are connected to A, you will now, that will be your starting node. So now from A, you will go to B. Why? Because B is having the minimum cost. So you will write A, B. It means you start from A and then you will move to B. From A to B, this cost remains same. So you don't need to write anything for this. Or you can say you already selected this node. So let me change it to a color B, red color, that I already used this node. In a similar way, we already used A also, because A is the starting node. Now, look at all the nodes which are connected to B. So B is connected to D, and the cost of it is, B is not connected to C. The first thing is that, so there is no change in the, can say, cost function and the root function of C. So now next is D, and B to D is, what is the cost now? B to D, the cost is 3, and you must use the root. You must use the root A to B. So A to B cost is 4, then B to D cost is 7. So the total is, I'm writing it for your reference. So the total cost is 3 plus 4. Or let me write it 4 plus 3. So it's 4 plus 3, because you are going like this and then this. So you are on B, but before to reach B from A, you need to use this cost function also. So it will be B4 plus 3. Then we write the next node only. So you are coming directly from B. But when you are coming to B, you need to use this distance also. So that's why the total cost of the distance is 7. Now, E. 12 is the cost to reach from B to E. And what is the cost to reach B from A? It's 4. So it will be 4 plus 12. And from where you are coming? From B. Then there is nothing else which is connected to B. So again, these all remain. So there is no route discoverable for these nodes at this point. So now these two remain same. So now again, you will look at these values also, which are not used, and so the cost is 16 from B to E. So for these nodes, there is no route discoverable at this stage, so they remain same. Now, to which node we will now jump? It will be decided by, we already used B marked by red, so we are not going to look at this node again. So now we will look at the node with minimum cost again. So it's 4 plus 3 is basically 7, and 12 plus 4 is 16. So out of these cost 16, you not look at this cost because we already changed this cost from 8 to 7. This is the minimum cost now. So 16, 7, 5. Which one is minimum? C. The next route is C. So I'm making it of red color again so that I know that I use this one also. So we will write here A, B, C. And now if you see C to B, there is no direct path between C and B, so you need not to worry about it. Now C to D, what is the cost? 1. And what is the cost to reach C? It's 5. So the cost total is 5, the cost to reach C, and the cost from C to D. So it's 6, and then you will write root as your C. Now C is connected to F and A. So we are not going to look at nodes which we already used for the purpose of reducing. So then there is no connection between C and E, so it will remain same. Here C to F. What is the cost between C and F? It's 11. And to reach C it's 5. So it's 16, comma, what's the root? C. There's no other node which is connected to C now. So they remain same. INF, I'm telling again, it's infinite, means the root is not discoverable yet. Now, if you see what this number is, this is 6. We already used C and B. Now we will see the cost to reach D now from A is 6. So it's not 8, 7, it's 6 now. This is the updated place. So now the nodes which are not used by us to discover the root are D, E, F, and the remainings are infinite. So infinite, you cannot figure out which infinite is larger or which infinite is smaller. All infinite are same. So if you compare these three, the minimum cost is by D. Select D, change the color to red, and then you write it here, A, B, C, D. Now, D, so this is the node, D to A. Even if you try to see the nodes which we already used, you will find that it will show you with a larger value. So what is the cost to reach D? It's 6. And if you want to go from D to A back, then it will be 8 plus 6, 14. So which is too much. But here you can see it's directly 6. So you don't see the nodes which you already used because they will provide you the higher value of cost. Now D to E. So D to E is 9, 9. And what is the cost to reach D? The cost to reach D is 6. So the total is 15, which is less than this value. So it will be 15, comma, D. Because we are now using node D. What is the cost to reach C? It's 1 if you go to the back side from D, and the cost to reach D is 6. So again, you can see that it's a larger value. That's why we don't see the nodes which we already used to reduce. Now, what is the cost to reach F from D? It's 4. What is the cost to reach D from A? It's 6. So the total cost is, I must write it in here in that way also, so that you can see it in the sequential way. So it's 6 plus 9 is the cost of this to reach D, and then from here to here. And then the cost to reach F is again cost to reach D plus the cost to reach F. So it's 4. And what's the root? It's D. Now D is now connected to G. What is the cost between them? 10. What is the cost to reach D? It's 6. So it will be 6 plus 10, comma, G. And what's the remaining? It's infinite because D is now not connected to any other node. Now, if you see, what is this value? It is 15. This value is 10. this value is 16. Now the nodes which are not used by us. So which node is minimum now? The minimum cost is 10 by F. So the next node will be A, B, C, D, F. It's not necessary that it is sequential that the next will be E. It depends on the cost here. Okay, so now we are going to use F, change the color now. So we are on node F. So the backward we usually don't see. If you want to check, you can check it again. You will find the value is always higher. So F to G, it's 5. And what is the cost to reach F? It's 15. Sorry, it's 10. So it's 10 plus 5. 10 from here and 5 from here. And through which node? It's through F. Now F is now connected to I. It's not connected to H, so it will remain INF. So it's connected to I with a number. Cost function is 11. And what is the cost to reach F? It's 10. So it will be 10 plus 11. Let me change it. So 10 from here and 11 from this to this. And there's no link between F and J. So again, the cost is INF or infinite. Now, we already used this. So the nodes which are not used by us is E. This is again 15. This is, we forgot to write 21, comma F. So out of this, we don't look at the nodes with cost equals to infinite. So it will be this, and this only. So if you see both of them have the same cost, node is not going to affect, only the cost will affect it. So you can pick any one. I'm just going sequential, so I'm using E. So now, so it will be A, B, C, D, F, E. Now from E to F, we don't need, and it's a backward thing also. So E to G and E to H. What is the cost from E to G? E to G, the cost is, E to G cost is 6, and the cost to reach E is 15. So what is the total cost? It will be 21, which is having a higher value. So we will not change it. We will leave it like that. If there is a change, we will use only the values. We'll only use the values which are giving us. So we are going to only use the values which are giving us the least cost to reach from one node to another. Now, so we are not going to change from the help of E anything with respect to G. Now, if you see E to H, the cost is 10. Earlier it was infinite. So it is 10 plus the cost to reach E. So it's 25, comma E. Now E to I, there is no connection. So it is remain same. E to J, no connection. So it will remain same as an INF. Let me insert one row below. So now what's left with us is G, H, I, and J. So which one is showing us the minimum value? 15 here. It's 25, it's 21. So we will use G. The next node in the network will be A, B, C, D, F, E. Now F, E, G, sorry. So we'll start from G. The cost to reach H is 3. And what is the cost to reach G? The cost to reach G is 15. So it's 15 plus 3 and it's through G. G to I, the cost is 5. And what is the cost to reach this? G, it's 15. So it's 15 plus 5, comma, G. Cost to reach J, it's 15 plus 15 and through G. Insert one row below again. So what is this? This is 18. We changed it because the value, earlier value is greater as compared to the newer value. And the cost is higher. 20, this is 30. Now, we on G, so we already use G. Basically, we need to make it red. Now, out of these, which one is showing us the minimum? It's H. So it will be G, H. So H. So you start from H, H to J, H to J. You just look the forward way. So there's no H or I. So there's H to J. So H to J is 14. What's the cost to reach H is 18. So it's 32. So there's no change. So this will remain same. So if we insert further, we already use this. Can say, however, we can finish this thing here, but I'm still showing you to the next step. Insert below, then so which one is lesser than them? It is I. Now I to J is 8. And what is the cost to reach I? It is 20. So we are using I, and the cost to reach it is now 28, comma I. So this is the complete diagram, or you can say the table, which the help of which you can find the cost starting from one point to another. Now, how this will be used to find the cost? You require to go from A to, let's say you need to go to J. So if you see, the cost is here is 28, and the root here is A, B, C, D, E, F, E, G, H, I. But if you see here, if I go from A to B, there's no root from B to C. So out of these, we will select the root which will help us taking to the reach J in minimum value. So what is the next point node we have here? From A to D. So we can use this route also, and we can use this route also. So whichever will cost us minimum, we will use that one. So A to B and B to D is 7, and A to C, C to D is 6. So out of these, let me write it here. Out of this, B will be eliminated. Now you are on D. So there are two things. There you go D, F, and then E, and then there's a G. So there's no way that you can go to F and then you can go to E. So you go to F. There's no way that you can go to E. So the node which is not coming in the root, you need to remove it from here. So it will be A, C, D, G, D, F ACDF. So you are on this node. Now, there are two possibilities here that you can go directly to I by removing both these, or you can take G and from G to I. So whichever is the minimum value, you will take that one. So it will be F to G and G to I. 5 plus 5 is 10. So which one you will remove from here? You will not remove anything. So you will go from G and G to I. So you will remove H from here. So that will be your I, and then where you want to reach? J. Now you add up your complete root. So it's 5 plus 1 plus, so it's 5 plus 1, then D to F plus 4, then 5 plus 5, this 5, and then 8. So that is your total cost, which is turned out to be, you can see it's 15. So it's 15, 520, it's 28, which is already there. The only difference is that you have to remove the nodes which are making you move away from your actual path. So this is the way the Dijkstra algorithm works. I'm going to create a network which I will be using on the basis of your creating it will be on the basis of your student number. So what I will do is, depending upon your student number, I will change these numbers. So maybe it will be the first digit, second digit, third digit, and I'll do it so that every student will get a different question. The question will not be same for all the students. So one thing you have to do this, and another one will be subnetting, which I will be doing on the same way. So hopefully I'll create the document today of your assignment, and I will send it to you tomorrow. And I'll create, and then I'll move towards the lectures. I'll post some more examples related to Dijkstra algorithm. I already posted 3 for subnetting, and I will send 1 or 2 more, and then you can start working on an assignment. Thank you.